Welcome to another AI pattern recognition deep dive.
Today, we're really opening up the hood on something that touches, well, pretty much everyone online. We're talking about the algorithms, the systems, the social technologies, AI or STA.
Exactly. This isn't just background noise. It's the invisible architecture shaping our digital world. And what we want to do today is give you a shortcut. We've waded through a lot of dense academic papers, industry reports.
Yeah, a real stack of them.
And the goal is to translate all that into clear takeaways. And the core finding, really, is that STA is profoundly dual-edged.
That duality is key, isn't it? That's the tension we need to unpack. Because on one side, you've got this immense potential, real innovation, solving problems, understanding social trends in real time, maybe even changing how organizations work for the better.
Absolutely. But then there's the other edge. And it's sharp. We're looking at systemic risks, threats to democracy, huge challenges to social equity, and maybe even something fundamental eroding, like our shared sense of what's real.
So understanding this tech isn't just interesting, it feels essential for navigating the world you live in now.
It really is.
Okay, so let's get a clear definition on the table. When we say STA, what exactly are we talking about?
Right. It's a specific, specialized field within AI. Its whole focus is on understanding, augmenting, and crucially, influencing human interaction, specifically in digital spaces.
And it's built on familiar AI foundations.
Fundamentally, yes. Machine learning, deep learning, those are the engines. But the application is unique. It's not just about data processing. It's trying to model human behavior, human interaction.
Which sounds incredibly complex.
It is. And the research reflects that. It sits right at this intersection of, core machine learning, but also human-computer interaction, HCI, and fundamental design principles.
And the methods used are pretty rigorous, according to the sources. Work coming out of places like IBM, big academic conferences like ACM-CHI. They're using a mix, right? Quantitative modeling and deep qualitative studies.
That's crucial. They're not just looking at the code in isolation. They're studying the influence of that code, the systemic effects on, well, billions of human interactions daily.
Right. And just a quick clarification, you might see STA pop up elsewhere. Maybe Science and Technology Australia, or that UK exercise tech thing.
Yeah, or even Singapore's defense assets. But that's not us.
No. Our focus today is strictly on these social algorithms, the systems governing our digital social lives, because that's where the stakes feel incredibly high.
Okay, let's dive into one of the most, well, frankly, intriguing ideas we found, conscious AI. The name itself grabs you, sounds a bit sci-fi, but sources frame this as a really significant strategic shift for STA, moving beyond just optimization.
Exactly. It's a pivot away from the kind of metrics that have really dominated platform design for, the last decade? Things like maximizing clicks, maximizing time on site, pure engagement number.
Right, the hamster wheel metric. It's sort of, yeah. Conscious AI is envisioned differently. It's seen as a potential catalyst, a mechanism for actual cultural transformation within communities, within large organizations. The goal is diagnosing and actively improving the, let's call it, systemic health and the ethical grounding of these groups.
Okay, that sounds like a massive leap for AI. Are we talking about AI as, like, an organizational auditor? Or, I don't know, a therapist for boardroom decisions?
Well, maybe not a therapist exactly, but the auditor analogy isn't bad. And it's grounded in data. These systems are designed to track something called conscious performance indicators, or CPIs.
CPIs, okay. Alongside the usual KPIs.
Right alongside the traditional key performance indicators. But CPIs monitor the quality of the environment. They look at softer but critical metrics, things like team coherence, ethical alignment in decision-making, even levels of creativity or psychological safety within a team.
But wait, how does an AI measure something as seemingly subjective as coherence or spot bias without being incredibly invasive? That feels like a very tricky line to walk. Isn't that just more surveillance?
That line is precisely what the research is grappling with. The idea isn't to monitor every private thought or action. It's designed to analyze the communication outputs of the group.
Outputs like meeting notes, emails.
Exactly. Using sophisticated natural language processing, it could, for instance, analyze meeting transcripts or internal digital communications project updates, things like that. It checks for alignment against a set of predefined organizational values.
So if the conversation consistently drifts away from those values, or maybe if one perspective just completely dominates all the time.
The CPI metrics would flag that. It spots a potential systemic imbalance. It's not policing the words themselves, but detecting patterns that suggest, say, a breakdown in collaborative health or an emerging bias.
So it's less about judging the content, more about detecting these potential cognitive blind spots in, like, real time.
Precisely. Let's take a scenario. Imagine a leadership team pushing hard towards a big decision. Everyone seems to be agreeing, maybe a bit too quickly.
Groupthink setting in.
Could be. The conscious AI wouldn't step in and say, stop.
Yeah.
But based on its analysis, maybe historical data shows this pattern leads to poor outcomes, or the CPIs detect a lack of diverse input, maybe signs of confirmation bias forming. It could actively suggest an intervention, like, analysis indicates viewpoints X and Y haven't been adequately considered. Recommend allocating 30 minutes to review counter-arguments before final commitment.
Wow. That's genuinely intelligent augmentation, isn't it? It's like building in productive friction where human biases or just, the rush to get things done might otherwise lead things astray.
That's the vision, and the sources are quite clear. This shift, prioritizing systemic health, ethical alignment over just raw speed or efficiency, is presented as the next ethical frontier in STA development.
It fundamentally changes the goalposts for AI design.
It does. The aim shifts from just making things faster or stickier to ensuring decisions are ethical, sustainable, and this is critical, equitable. It's about trying to embed social responsibility into the AI from the very beginning, not just bolting it on afterwards.
Okay, let's shift gears a bit and look at the mechanisms that are already running the show in our daily digital lives. Social technologies AI, it's basically the infrastructure, right? And the first core function is probably the most obvious one. Content curation, recommendation systems.
Oh, absolutely. These systems are the engine room of modern platforms. They determine what you see, when you see it, who you see it from. It's a powerful mix of technologies.
Likewise.
Well, machine learning is key for generating those personalized recommendations. Natural language processing, NLP, is crucial for understanding text posts, comments, articles, and computer vision is needed to make sense of all the images and videos flooding these platforms.
And the driving goal is always optimization,
right?
Maximum engagement.
Pretty much. They use predictive analytics, incredibly detailed models of user behavior to forecast trends, figure out what's going to capture attention next, and sometimes maybe even anticipate what a user might want or desire before they even consciously realize it themselves.
That predictive power is kind of staggering. But it creates attention, doesn't it? Something the sources called the authenticity paradox.
Yes, that's a really important concept. On one hand, AI could theoretically help creators make better, more valuable, more human-centered content, help them sift through that massive fire hose of data to find genuine insights about their audience.
Okay, so the AI provides the deep insight, helps the creator tailor the message. That sounds good. Where's the paradox?
The paradox kicks in because the creator isn't just creating for their human audience anymore. They're also creating for the algorithm.
The mysterious algorithm, always trying to guess what it wants.
Exactly. And that constant pressure, what do I need to do to get the AI to show my stuff? It compels creators towards, well, sometimes cheap tricks. Clickbait, jumping on fleeting trends, optimizing purely for those surface-level engagement signals.
Because that's what they think the algorithm rewards.
Precisely. And the end result, over time, is this gradual commoditization of social content. Everything starts to look and feel the same, optimized for the machine. It arguably diminishes the value of genuine, complex human interaction because it all gets flattened into an engagement score.
And that intense competition, that drive, feeds right into the next massive challenge for platforms, platform integrity.
Which brings us squarely to the moderation dilemma. This is maybe the most visible, most debated aspect of STA.
The sheer scale of user-generated content is just mind-boggling. Posts, images, videos, comments, billions every day.
Yeah.
Humans simply cannot keep up.
No chance. So AI-powered moderation systems are absolutely vital. They're the first line of defense, scanning massive volumes of content for violations much faster and at a scale humans could never achieve. Basic platform hygiene depends on it.
But then, generative AI throws a massive wrench in the works, doesn't it? It's got this dual role.
It really does. It's a complex loop. Because on one side, generative AI is the engine driving the explosion of synthetic content, low-quality stuff, potentially harmful deepfakes, derivative posts. It massively increases the sheer volume that needs moderating.
So it creates the problem.
But it also has to be part of the solution. Advanced STA is now being used to combat these issues. detecting deepfakes, for example.
How does it do that?
By analyzing tiny, almost imperceptible inconsistencies, minute flaws in visual elements, subtle artifacts in audio, weird phrasing and language patterns that a human might easily miss, especially at speed. It's essentially AI being trained to spot the fingerprints of other AIs.
AI fighting AI.
Pretty much. But even with these advanced detection tools, the consensus among the experts cited is clear. The best approach, the most robust one, is still a hybrid model.
Meaning machines plus humans.
Yes, machines provide the scale, the initial filtering, but human judgment is still essential for nuance, for context, for making the really difficult calls accurately.
Which brings us to that really difficult ethical trade-off regarding the moderators themselves. Their psychological safety.
Yeah, this is a painful one. To protect human moderators from constant exposure to truly horrific, abusive, or graphic material, platforms are developing and using AI techniques like visual question answering VQA.
VQA, how does that work?
Instead of looking directly at, say, a potentially violent image, the moderator can ask the AI questions about it. Does this image depict illegal activity? Is there blood visible? Is the subject of this video clearly underaged? The AI answers, and the human makes a decision based on the AI's description without direct visual exposure.
That sounds vital for protecting the mental health of moderator. I can't imagine doing that job day in, day out.
It's incredibly important. But here's the trade-off. The sources are very clear on this. This protective VQA technique is acknowledged to be less reliable than direct human review.
Less reliable. How so?
The AI's interpretation might miss crucial context. It might misinterpret nuance, sarcasm, or cultural specifics. This could lead to mistakes, either harmful content staying up when it shouldn't, or legitimate expression being taken down unfairly. You are explicitly trading some degree of platform accuracy for moderator psychological safety.
Wow. That's a necessary compromise, perhaps, but a really stark one.
It highlights the deep ethical complexities here.
So given this flood of content, especially AI-generated harmful stuff, what's the recommended policy approach? Do we need new rules specifically for AI speech versus human speech?
Actually, the recommendation from the research is pretty straightforward. Keep it simple and focus on the harm. Double down on existing technology-neutral content moderation policies, meaning rules that target damaging speech, hate speech, incitement to violence, dangerous misinformation, regardless of whether a human or a machine created it. The threat from an AI-generated deep fake spreading lies isn't fundamentally different in kind from human-generated lies. It's just the scale and potential believability that's amplified. Trying to create separate rules for AI content just adds complexity and potential loopholes. Focus on the harmful output, not the origin.
That makes sense.
Yeah.
Okay, let's move to the third core function. And this is where things get really interesting if you're involved in business, marketing, anything commercial. Commercial targeting. We're way beyond simple ads now, right?
Oh, light years beyond. This is about hyper-specific personalization, driven by AI's ability to process absolutely vast data sets in real time. We've moved past traditional demographic buckets, age, location, gender, into the realm of individual preferences, microsegments, real-time behavioral triggers, understanding what someone might do next.
It's about predicting action based on a huge number of signals.
Exactly. And the business impact is transformative. It allows for these hyper-personalized marketing campaigns that can feel almost one-to-one, product recommendations that seem spookily accurate, and even real-time adjustments to add content or strategy based on detected shifts in consumer taste or behavior, sometimes changing midstream while you're scrolling.
And this isn't just happening on social platforms, is it? It's integrated deeper.
Deep into enterprise systems. Think about tools like Google Analytics, Adobe Sensei, IBM Watson, Salesforce Einstein. These aren't just dashboards. They have sophisticated AI engines underneath.
Doing what?
Doing advanced predictive modeling. Forecasting customer lifetime value, predicting churn risk, identifying optimal engagement strategies, understanding market sentiment shifts almost instantaneously. It allows businesses to make incredibly dynamic, data-informed decisions about product development, marketing spend, customer service. It's a continuous feedback loop.
Making the market feel incredibly responsive, almost alive.
In a way, yes. Driven by these constantly learning AI systems.
All right, let's shift our focus again, this time to the real cutting edge of the research. Trying to simulate human social dynamics. Why is simulation so important for understanding STA?
Well, because the real world is messy. The actual mechanisms that govern how information spreads, how opinions form, how polarization happens in these huge, complex social networks, They're often really opaque. We see the outcomes, but understanding the underlying rules is incredibly difficult.
We have tons of data, but not necessarily the rule book.
Exactly. So AI becomes necessary. We need AI to analyze the data, try to learn those hidden interaction rules, and then use those rules to build what are called surrogate models. These are simulated environments that can hopefully forecast how the whole system might evolve if you change something or under different kinds of stress.
And leading this charge, according to the sources, is something called the OASIS architecture, open source agent-based social media simulation. Sounds ambitious.
It is genuinely sophisticated research. OASIS is really at the forefront here. It's clever because it integrates powerful large language models, LLMs, with more traditional, predictable, rule-based agents.
Why that combination?
The LLMs give the simulated users the agent's realistic linguistic abilities. They can post, comment, argue, respond in ways that feel human. But the rule-based part ensures they adhere to certain behavioral parameters or simulated personality traits, making the simulation controllable and repeatable.
What kind of scale are we talking about? How many simulated users?
It's pretty staggering. OASIS can reportedly mimic the behavior of up to 1 million users simultaneously.
1 million.
A million interacting agents on simulated platforms designed to resemble places like X or Reddit. And critically, this isn't just some theoretical toy model.
It's been tested.
Validated rigorously. The architecture is designed to be generalizable. It includes dynamic environments, simulated recommendation algorithms within the model, and agents capable of performing dozens of different social actions: posting, commenting, liking, sharing, blocking, following, the works.
And has it successfully replicated real-world social phenomena?
Yeah.
Because human behavior online is, well, famously chaotic.
It has. The researchers have managed to replicate complex observed patterns, things like how certain types of information propagate faster than others, the emergence of group polarization dynamics, even specific herd effects like agents being more likely to upvote a post if it already has simulated upvotes.
Mimicking that social proof element.
Exactly. And one really interesting finding came out regarding scale. They found that simulating with larger groups of agents actually led to more enhanced, complex group dynamics emerging. And maybe counterintuitively, it also produced more diverse and helpful opinions among the agents in some scenarios.
More agents led to more diversity. That does seem counterintuitive, especially given what we see online.
It suggests scale itself might be a factor influencing network health in ways we don't fully grasp yet.
Which brings us right to the thorniest problem these simulations are tackling: the seemingly intractable issue of polarization and the formation of echo chambers.
Yeah, and this is where the research findings get, frankly, quite disturbing. Simulations using very advanced AI chatbots, the kind powered by models like GPT-4o, were placed into simple, simulated social media environments. Critically, these environments had no complex engagement-maximizing algorithms.
It's the basic network structure.
Right. And what happened? Consistently, the AI agents self-sorted into echo chambers. They clustered based purely on their pre-assigned affiliations or initial opinions, even without an algorithm pushing them there.
Hold on, let me make sure I heard that right. You're saying even if we got rid of the recommendation algorithms we usually blame for filter bubbles, the fragmentation, the echo chambers might happen anyway.
That's the deeply unsettling implication from these simulations. This tendency towards fragmentation, towards like-minded clustering, appears to be an incredibly robust characteristic of just network digital interaction itself. And to really test how deep this runs, the researchers did this, well, eye-opening experiment. They tested 6 different strategies, 6 interventions specifically designed to try and prevent polarization from happening in their simulation.
Okay, this sounds crucial. What kind of interventions did they try? Things we often hear suggested as fixes.
Exactly. Things that seem intuitive. For instance, they tried implementing a purely chronological news feed, taking any algorithmic filtering out of the equation.
Get rid of the recommendation bias. Makes sense. What else?
They tried hiding social statistics, getting rid of counts, share counts, the idea being to remove those superficial validation pressures that might drive certain behavior.
Reduce the popularity contest aspect, okay?
They even tried actively boosting diverse viewpoints, so the system would artificially inject content from opposing perspectives into an agent's feed, trying to break the echo chamber walls.
Forcing exposure to different ideas. That sounds like a good strategy. And what was the overall outcome of these 6 interventions?
The outcome was, in their words, disturbing. None of the 6 strategies managed to prevent the simulated social system from devolving into a polarized state to a satisfactory degree.
None of them worked effectively?
Not effectively enough. And worse, in some cases, the interventions actually seem to worsen some negative dynamics.
Can you give an example of that, where a fix made things worse?
Sure. The chronological feed intervention. On the surface, it did reduce attention inequality posts, got a more even viewing. But the side effect was that extreme, inflammatory, or low-quality content surfaced much more frequently and quickly.
Why?
Because the chronological feed removes any kind of quality or popularity filter. If an agent posted something extreme, it just appeared in everyone's feed immediately, regardless of whether anyone agreed with it or found it valuable. So it actually increased exposure to the most divisive content. It basically traded one kind of systemic harm for another.
That really throws cold water on the idea that we can just tweak platform design, change the feed algorithm, and magically fix societal division.
It seriously challenges that assumption, and it leads the researchers to propose what they call the systemic property hypothesis.
Me.
The hypothesis is that polarization, this tendency towards fragmentation, might not just be a bug in specific proprietary algorithms that we can patch. It might actually be an emergent systemic property rooted in the fundamental dynamics of social physics and how humans behave and update opinions in networked environments.
Like it's baked into the physics of online social interaction itself.
That's the suggestion, which implies that fixing it might require much deeper changes, potentially addressing cognitive biases or social dynamics outside the platforms rather than just fiddling with platform features.
That's a heavy thought. Okay, let's shift to a related challenge. Conducting this kind of research in what's being called the post-API era. Computational social science needs data, right? Massive amounts of it.
Traditionally, yes. But platforms are increasingly locking down their APIs, restricting the flow of data to independent researchers. This creates a huge structural barrier. Researchers often have to rely on static snapshots of data, which quickly become outdated.
So how are researchers adapting?
Well, interestingly, advanced web browsing large language models are emerging as a potential new, albeit controversial, data collection tool. These LLMs can be tasked to go out and retrieve, interpret, and synthesize publicly available social media content at incredible scale and speed.
And they're good at it, not just scraping, but understanding.
They excel at the nuance, identifying complex sentiment, detecting subtle bot-like behavior, understanding linguistic context, extracting relationships, tasks that were very difficult before.
Okay, that sounds useful for research, but you said controversial.
Because this same capability introduces a profound dual risk, the ability for what's being termed zero data profiling.
Zero data profiling, meaning building a detailed profile on someone using only publicly available information without needing any special access from the platform.
Precisely. An LLM could potentially be tasked to scrape public tweets, forum posts, blog comments, maybe cross-reference them with other public data like voter registrations or location check-ins.
And build a sophisticated political or commercial profile on millions of users.
Exactly. It offers a potentially low-cost, highly scalable method for malicious actors, think state-sponsored influence operations, or maybe unscrupulous commercial entities to conduct targeted profiling for political manipulation or predatory marketing.
That's cell-chilling. It bypasses platform privacy controls entirely.
It does, which poses a massive governance challenge. How do you enable legitimate research using these powerful tools while preventing their misuse for mass surveillance or manipulation?
What are the recommendations?
The sources strongly argue that LLM providers themselves have a responsibility here. They need to proactively build in restrictions to limit this kind of deep, individual profiling capability in their public-facing general use applications.
Put guardrails on the public models.
Yes, while simultaneously finding ways to provide strictly controlled, secure access to these capabilities for verified academic researchers, journalists, and potentially oversight bodies. It's about creating necessary friction to balance the potential for harm against the need for scientific understanding and public accountability. Okay, let's really confront something critical now. Algorithmic bias. We need to be crystal clear. This isn't some random glitch or bug in the code. The research confirms bias is actively ingested by these systems, primarily from the data they learn from.
And integrating AI into social tech, well, it immediately throws up huge red flags for fairness and ethics, doesn't it?
Huge. So let's unpack the mechanics. The research points to three main systemic sources of this bias. First up, historical bias.
Meaning the AI learns our past mistakes.
Essentially, yes. AI systems are trained on vast amounts of historical data, text, images, records. And that data inevitably reflects and encodes the biases, stereotypes, and inequalities that existed in society when the data was created.
Like gender stereotypes in old texts.
Exactly. We see structural gender bias embedded deep within word embeddings used for language generation, which then get perpetuated when the AI writes new text. Or think about image recognition systems trained primarily on pictures of lighter-skinned individuals struggling to accurately identify people with darker skin tones.
Can you give a concrete example where historical bias causes real harm?
A really clear and impactful one is in automated speech recognition ASR systems. Think voice assistants, transcription software.
Yeah, used everywhere now.
Studies have consistently shown that these ASR systems have significantly higher error rates when processing the speech of African Americans compared to, say, demographically matched white Americans, sometimes over 30% higher error rates.
30%. Why such a big gap?
It comes back to the training data. If the AI was trained predominantly on a data set skewed towards one type of accent or dialect, it simply struggles to accurately parse the rhythm, the intonation, and the specific vocabulary of other dialects, like African American Vernacular English, AAVE.
So the technology itself ends up being less reliable, less functional for an entire group of people just because of the data it learned from.
Precisely. It unintentionally reproduces and reinforces existing systemic inequalities by creating a functional disadvantage.
Okay, that's historical bias. What's the second source?
Representation bias. This is also known as sampling bias, or sometimes availability bias. It's fundamentally a data quality and data collection problem.
How so?
It happens when the data set used to train the AI simply doesn't accurately reflect the diversity of the population it's going to be used on. Sampling bias is classic. Maybe you scrape data only from Reddit or only from Twitter. That data isn't random. It's not representative of everyone.
It reflects the user base of that specific platform.
Right. And availability bias is even simpler, but maybe more pervasive. Data gets selected just because it's easy to get, because it's readily available, not necessarily because it's the best or most representative data for the task.
So certain groups just get left out or underrepresented in the training data because harvesting their data was harder?
Exactly. Marginalized groups, women in certain contexts, non-Western cultures, people with disabilities, linguistic minorities, often end up systematically underrepresented simply because they weren't adequately present in the conveniently available data pool. The AI literally doesn't learn enough about them.
And the third source sounds particularly tricky. Bias through proxy variables. This is where the algorithm isn't using the forbidden variable, like race, but uses something else that stands in for it.
This is one of the most insidious challenges in trying to debug AI for fairness. Let's say you're building an AI system to assess credit risk. You're legally forbidden from using race as a factor.
Right.
But what if the algorithm uses postal codes or zip codes? In many societies, postal codes correlate very strongly with racial demographics and socioeconomic status due to historical segregation and inequality.
So even though the algorithm isn't explicitly looking at race, using the postal code effectively achieves the same discriminatory outcome.
Exactly. The postal code acts as an unfair proxy for race, inadvertently disadvantaging entire communities even though the system looks race-blind on the surface.
It seems clean, but the bias is still baked in through this stand-in variable.
Precisely. Another common example comes from text classifiers. They might learn from historical text data that professions like engineer or doctor are strongly associated with men, while nurse or teacher are associated with women.
Based on past rating patterns.
Right. Now imagine a hiring recommendation system uses that classifier. Even if it never explicitly looks at an applicant's gender, its underlying associations might lead it to systematically favor male candidates for engineering roles and female candidates for nursing roles, just based on the language in their resumes. It perpetuates the bias without ever seeing gender directly.
So the bias gets ingested through these data issues, but it doesn't just sit there passively, does it? The system's design then actively reinforces it. Let's talk about how that creates the infamous filter bubble.
Absolutely. Bias isn't just static, it's dynamic and self-reinforcing. Algorithmic design choices play a huge role. Developers, often optimizing purely for engagement or connection metrics, might embed subjective rules or weight certain factors unfairly. They might prioritize content that's sensational, agreeable, or simply similar to what the user has clicked on before.
And those design choices fuel the feedback loops.
Directly. The system suggests content based on its biased understanding of you and the world. You click on something it suggests because it's tailored to your bubble. The algorithm sees that click as positive reinforcement. They like that.
And it doubles down, showing you more of the same.
Exactly. Creating a tighter and tighter feedback loop around your existing worldview, your existing biases, that continuous reinforcement is the filter bubble mechanism.
It isolates you.
It limits your perspective, makes it harder to encounter challenging or diverse viewpoints, reinforces existing political and social divisions, and it ensures that the initial bias, ingested from flawed data, becomes dynamic and self-exacerbating over time. The system learns from a skewed reality and then actively amplifies those skews.
Okay, this sounds deeply embedded. How do we even begin to fight this pervasive recursive bias? What are the mitigation strategies proposed?
It has to be a multi-pronged approach, starting with policy and governance. The sources stress mandatory end-to-end policy integration. That means establishing robust internal governance first.
Like what?
Things like having a dedicated AI ethics lead, maybe an ethics board or council. Crucially, internal policies must explicitly prioritize equity as a core objective for AI systems, putting it on par with or even above pure efficiency or engagement metrics.
So build fairness into the goals from the start. Once that policy foundation is there, what about operations? The sources mention a kind of debugging process.
Yes, think of it like debugging code, but for bias. There are 3 key operational steps recommended. First, inventory algorithms.
Just list them all.
Systematically, every single algorithm being used or developed in the organization, and assign clear oversight responsibility, ideally to someone at the C-suite level, to ensure accountability. You'd be surprised how many organizations don't even have a complete list of the AI systems they're running.
Okay, inventory first, then.
Second, screen for bias. This needs to be rigorous. Treat it like quality assurance. You have to assess the inputs. Is the training data diverse? Is it representative? And you have to scrutinize the outputs. Critically, this involves actively hunting for those subtle proxy variables we talked about. It requires continuous auditing, not a one-off check.
Finding the hidden biases. And the third step.
Retrain and improve. If an algorithm is found to be biased, it can't just be left running. It needs to be suspended or actively improved. Improvement itself is complex. It might involve retraining the model using demonstrably more diverse, more representative, or more accurately labeled data. Or sometimes it involves adjusting the prediction target. Maybe instead of predicting purely based on historical biased outcomes, you train the AI to predict a slightly different, more equitable outcome. This requires active, ongoing intervention and refinement. It's not a one-and-done fix.
Let's pivot now to perhaps the largest scale societal threat that STA poses, the danger to democratic integrity itself. And this really starts with the sheer scale of the infodemic, turbocharged by things like deepfakes.
Yeah, the AI era has taken the existing problem of misinformation and just put it on steroids. Large language models make it incredibly easy for bad actors to automate the generation of fake news articles, social media posts, propaganda.
Stuff that sounds plausible, realistic.
Frighteningly realistic, linguistically speaking. And it can be mass-produced at a scale and speed that was previously unimaginable. This fundamentally changes the information landscape.
And it's not just text, is it? The visual side is escalating dramatically. We're seeing things like instant video generators.
Tools like Sora, yeah. These advances enable the creation of high-quality, sometimes Hollywood-level deepfake videos and audio. Fake speeches, fabricated events, audio clones, things that can be incredibly difficult for the average person to distinguish from reality, especially when encountered casually online.
What do the numbers look like on this?
The reports cited are pretty alarming. One indicated a 5-fold increase in deepfake content detected year over year. Another pointed to influence operations utilizing over 12.8 million fake online personas to spread coordinated disinformation campaigns.
12 million fake accounts, just for influence ops.
It creates a genuine infodemic, a confusing, polluted information environment where discerning truth from fiction becomes exhausting, if not impossible. And that poses profound dangers to the shared understanding of facts that democracy relies on.
Which feeds directly into what seems like the most critical long-term danger, the erosion of cognitive trust.
Absolutely. We know social media algorithms, often optimizing for engagement, tend to amplify content that aligns with our existing beliefs. This reinforces polarization, creates echo chambers. But the deeper danger, the truly systemic threat, isn't just that a specific deepfake might persuade someone politically.
What is it then?
It's the systemic destabilization of our collective trust in information itself. The erosion of the shared sense of objective reality that's necessary for any kind of reasoned public debate or democratic functioning.
So if you, as an average voter, are constantly bombarded with information online, and you increasingly suspect that any video could be fake, any quote could be fabricated, any image could be manipulated. What's the rational way to protect yourself mentally?
Well, the rational cognitive defense mechanism, tragically, might be to adopt a kind of nihilism, the decision to simply believe nothing, or perhaps to only believe sources within your pre-existing tribe.
Because trusting anything outside feels too risky, too uncertain?
Exactly. When citizens feel they can't reliably trust the evidence presented to them, they retreat. This widespread loss of social trust in information is incredibly corrosive. It forces people to rely more heavily on cognitive shortcuts, tribal heuristics, partisanship, identity politics, because engaging in evidence-based debate feels pointless if you can't agree on the evidence.
And that just feeds back into the polarization loop.
Viciously. It damages the credibility of traditional sources of rigorous fact-check journalism as well, because everything gets lumped into the potentially fake category.
Okay, it's a grim picture. What are the defense strategies? We must be able to fight back, right?
Yeah.
Using AI itself.
That's definitely part of the solution. Fighting AI with AI. Using sophisticated detection algorithms to identify and flag or filter misinformation early in its diffusion stage before it spreads too widely.
Has that approach been shown to work?
Yes, there are examples. During the early stages of the COVID-19 pandemic, AI-driven detection and filtering systems were deployed, and studies showed they significantly reduced user exposure to harmful medical misinformation. It requires constant vigilance, updating the detection models, and crucially, collaboration between the tech platforms and human fact-checking organizations.
What about the policy and regulation side? What's needed there?
Transparency and accountability are paramount. Policy needs to focus on regulating the outputs, the harmful content itself, as we discussed, but also on demanding much greater transparency about the inputs. The massive data sets used to train these foundational models need to be audited, understood, and potentially regulated.
Know what the AI learned from.
Exactly.
Yeah.
Transparency in how algorithmic recommendations work is absolutely fundamental for accountability. You, as a user, have a right to understand why you're being shown certain content and not other content.
And beyond tech and policy, there's the human element, right? The cognitive defense.
Yes, the long-term cognitive prophylactic, as some call it. This means seriously investing in media and information literacy programs for everyone, all age groups.
Teaching critical skills.
Skills like how to track down original sources, how to cross-reference information across different outlets, how to spot the telltale signs of synthetic media or manipulative framing. Since we probably can't entirely stop the flood of bad information, we have to equip people with the critical thinking skills to navigate it safely and make informed judgments. Teach people how to swim in the information current. So, looking ahead, it's clear that technological innovation here is moving incredibly fast, often much faster than government regulation can keep up. This means immediate, comprehensive ethical guardrails are not just nice-to-haves, they're necessities.
Because the cost of getting it wrong is huge, right?
Yeah.
Fines, operational problems, massive damage to public trust.
Exactly. A lack of diligence isn't just unethical, it's bad business. So let's quickly review the core ethical pillars that global bodies and researchers are advocating for, the things that need to be mandated for responsible STA development. First, human oversight and determination.
Meaning humans stay in charge.
Fundamentally, yes. AI should augment human capabilities, enhance decision-making, but not replace human judgment entirely, especially in high-stakes situations. Ultimate responsibility and accountability must remain clearly with humans.
Okay. Second pillar, transparency and explainability.
This is crucial. Users, regulators, everyone affected needs to be able to understand how these systems function, what their limitations are, and critically, what data and logic inform the AI's recommendations or decisions. Without explainability, you can't have meaningful accountability or trust.
Makes sense. Third, fairness and non-discrimination.
This ties back directly to the bias issue. STA developers and deployers have an active obligation to promote social justice and actively mitigate the risk of perpetuating or amplifying real-world biases, especially concerning protected characteristics like race, gender, etc. It requires a proactive, equity-first mindset.
And fourth pillar, robustness.
Systems need to be secure. They must be actively designed and defended against adversarial attacks, situations where bad actors try to deliberately poison the training data or manipulate the system's outputs to cause harm or gain an unfair advantage. Ensuring the systems are reliable and secure is key to building confidence.
So those are the core principles. And we're seeing institutions respond, right? Major universities like MIT, Boston University, Tufts. They're setting up dedicated centers for AI ethics and social impact.
Yes, that academic mobilization is a really important counterweight to purely commercial development. MIT's AI Policy Forum, for example, is focused specifically on translating those abstract ethical principles we just discussed into concrete, practical, enforceable policy recommendations.
Trying to bridge the gap between ethics theory and real-world rules.
Exactly. Boston University has an accelerator focused on empowering community members with the tools and frameworks to use AI responsibly. And Tufts TIAI Institute is explicitly centered on AI for social good, trying to accelerate scientific discovery using AI while ensuring it improves global well-being in areas like healthcare, climate science, and evidence-based policymaking.
That focus on public good, on social impact, makes the final point we found in the sources particularly, well, stinging. It highlights what's called the strategic failure of financial asymmetry.
Yeah, this is perhaps the most revealing structural issue in the entire STA landscape today. The data shows something really interesting. On one hand, over 70% of organizations identifying as social innovators have apparently deployed some form of machine learning for social impact projects.
Okay, so the tech is being used for good causes. People are trying.
People are trying, and the technology is capable. That's the positive signal. But then you look at the money, the financial imbalance is just profound.
How profound are we talking?
Less than 1%. According to the reports we analyzed, less than 1% of total global corporate investment in AI is currently being allocated to these kinds of impact-focused, socially beneficial applications.
Wait, less than 1%. So 99% plus of the corporate money is going elsewhere.
Overwhelmingly, yes. It's going towards profit-driven STA applications. Refining advertising engines, optimizing user engagement for commercial platforms, developing high-frequency trading algorithms, market prediction, customer acquisition.
Stuff that directly drives revenue.
Exactly, which means that the applications designed to make money receive vastly disproportionate amounts of resources, talent, funding, and computational power compared to research aimed at mitigating AI harms, improving platform integrity, fostering equity, or solving societal problems.
That's a staggering imbalance. What's the implication of that 99-to-1 gap?
The implication is that we have a massive, self-perpetuating ethical deficit built into the system by resource allocation. The very technologies that structure so much of our social interaction are being developed and optimized almost entirely for shareholder return, not for social cohesion, democratic health, or public well-being. This fundamental asymmetry actively exacerbates nearly every systemic risk we've discussed today. Addressing this imbalance isn't just a side issue, it's central to changing the trajectory of STA, #tagoutro.
So wrapping up this deep dive, it really hammers home the fundamental duality of social technologies AI. On one side, you have this incredible, almost unprecedented analytical power. We see it in the potential of conscious AI to monitor organizational health, or the complex simulations like OASIS trying to model society itself.
But that power rests on a deeply troubled foundation. The reliance on historically biased data, the optimization overwhelmingly geared towards profit and engagement, it almost guarantees that bias gets reinforced and polarization gets amplified. Those failed intervention experiments and the simulations are a stark reminder of how deep-rooted these problems might be.
Yeah, that was sobering. So the path forward, it seems challenging, but the direction is clear, isn't it? It requires mandatory ethical oversight integrated right from the start. It demands enforceable transparency. It means tackling that zero data profiling risk head on, and somehow structurally rebalancing that huge financial asymmetry that currently starves socially beneficial AI while pouring resources into engagement optimization.
Absolutely. The governance choices we make right now, collectively, about how we develop and deploy STA will likely determine whether this powerful technology ultimately helps society flourish or pushes us further towards fragmentation and distrust.
Which leads us to our final provocative thought for you, the listener, to chew on.
Given that these rigorous simulations suggest political polarization might be something deeper, maybe a fundamental systemic property of social physics, something highly resistant to simple platform design fixes, if tweaking the algorithm isn't enough, what does that mean? What are the deeper cognitive biases, the social dynamics of how we form and update opinions that society needs to address outside of just regulating the platforms themselves? If the platforms alone can't fix fragmentation, where does the responsibility truly shift? Is it education, media reform, changes in political culture, something else entirely?
A lot to think about there. Thank you for diving deep with us today.
Searching for answers to unanswered questions.
This is DigitView.